Today we're going to start talking about magnitude. Magnitude is a measure of how large or small a number is. Specifically, magnitude is the power or the exponent on the 10 in scientific notation. We're going to look at putting this number here, m, into a power of 10 that will exceed it. That means I'm going to look at my first digit on the left-hand side, which is 7. I need to change that to a 10, and I need to make everything else a 0. When I count them, I can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. If there are 10 zeros, that means my exponent should be 10. So writing this as a power of 10, that is 10 to the 10th power. I can also look at numbers that are less than 1. In this case, we have 0.0003 grams. If I read that, that is in the 10,000th place. Starting at the first digit after the decimal, this is the 10th place, the 100th place, the 1000th place, and then finally the 10,000th place. That means I have literally 3 10,000ths. So 10,000 is in my numerator. The numerator, 10,000, has 4 zeros. So I know the power has to be 4. But since it is in the denominator, the 4 should be negative. That means I have 10 to the negative 4th power. The magnitude is -4, because written as a power of 10, this is 3 times 10 to the negative 4th power. Let's try this one together. We're going to look at the number furthest to the left. That's this 9 here. We have to make that into a 10. So basically what we're doing is we're adding a place value. Everything else is going to be a 0. This 9 is going to be a 10. That means we're going to have a 1, and where that 9 was, a 0. I fill in the rest of my zeros. This would have been 4, 5, 6. This would have been 7, 8, 9. This would have been 0, 9, 8. And this would have been 7, 6, 5. These are all zeros. The next thing I'm doing is I'm counting my zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that means I have 10 to the 15th power. I can look at the same process with the next number, except I note that I've got a fraction on the end. That fraction is just like a decimal, it's less than 1, so I just have to round my number up if I want something bigger than it. So instead of having 78,491, I have 78,492. Now I need to find the smallest power of 10 that will be bigger than this number. What I'm going to do is I'm going to look at the 7 and change that to a 10. That 0 is where that 7 would be, a 0 for where the 8 would be, a 0 for where the 4 would be, a 0 for where the 9 would be, and a 0 for where the 2 would be. Then I count my zeros. 1, 2, 3, 4, 5. That means I have 10 to the 5th power. Please pause, try the you do, and then check your answer here. Again, please press pause now. Reading through the question, I see that I have 1 in 10 trillion. That means that this is a fraction, 1, and the fraction bar is the in part. On the bottom, in the denominator, I know that I should have a 1 followed by 13 zeros, because if 1 trillion has 12 zeros, 10 trillion is a 10, with 12 zeros after it. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if the 10 has 12 zeros after it, that makes a total of 13 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That means I have 1 over 10 to the 13th power. Now if I have a positive in the denominator, I can make that a negative in the numerator. So in order to bring this up here, I say it's 10 to the negative 13th power. And this is your final answer.